Welcome. This is Weeds and Wellbeing, Flowers and Pollination by the Heirloom Seed Sanctuary, Sisters of Providence of St. Vincent de Paul. My name is Kate Henderson. I'm the presenter for today, and I am the gardener and seed saver at the Sisters of Providence of St. Vincent de Paul Heirloom Seed Sanctuary. You can address questions by email through the course of this webinar, and we will answer them as soon as possible. The Heirloom Seed Sanctuary is a ministry of the Sisters of Providence of St. Vincent de Paul. It is a sanctuary for a collection of locally adapted seeds brought here in the late 90s by local organic gardeners Carol and Robert Moak. The seed collection includes vegetable, flower, and herb varieties that they grew for their market garden. Onions, cucumbers, tomatoes, lettuce, beets, and carrots, spinach, peas, beans, and almost any other commonly available variety of vegetable. The Heirloom Seed Sanctuary defines the word heirloom to mean a variety that either has been or is worthy of being passed down through generations, just as furniture and other items are lovingly made to this day for the purpose of being passed down in families. Heirloom varieties are always open-pollinated, which means, according to the Bauta Family Initiative on Canadian Seed Security, open-pollinated, or OPs, produce seeds that closely resemble the parent. OP varieties are a result of combining parents that are genetically similar. If you plant an OP, save seed, and grow that seed the next season, the plants will look like the ones you grew last year. One of my seed-saving teachers has been John Navazio, organic plant breeder and author of the book, The Organic Seed Grower. He begins his book by explaining the significance of seed saving. Seed is the vital link to our agricultural past. All of the changes that have occurred in the domestication of our crops are a reflection of the ingenuity and perseverance of our agricultural ancestors. This is even more wondrous when we realize that all of the plants we rely on for our very existence are derived from wild plants that were not usually succulent. In fact, they were often bitter or sour, far beyond what our modern palates would tolerate. The modern crops that grace our tables daily are all derived from a much larger number of plants that were found to be edible and were used extensively by our hunter-gatherer forebears. While natural selection had already shaped these wild plants, the selection pressure of the people who first grew them under cultivation further changed them to better suit their needs. These webinars are for beginner seed savers, those who are just starting to develop their relationship with a particular favorite vegetable, flower, and herb plant variety. Seed saving can be complicated, but for some plants it is quite simple. So we will focus here on those simpler types so that you can experience success and lay a foundation on which to build your seed saving practice. I believe that we are all born seed savers, since in essence, seed saving is just sorting desirable plants from undesirable plants, good-tasting fruits from bad-tasting fruits, whole healthy seeds from less desirable seeds, etc. Just watch a child with a box of Smarties candy and you'll see how we do this naturally. In live workshops, I do this exercise with adults and the same pattern arises. See the chipped, damaged blue Smartie? That one got popped into a mouth right away. It was no good for saving. We want to help you develop the precious relationship of midwife to your plants, and to this end, this series will come full circle, with one episode every other month from starting with stored seed all the way around to storing your harvested seed. These webinars are based on a workshop series that was hosted originally by Carol and Robert Moak until 2008, and then by myself. It is a series of seasonal workshops, each of which is timed according to what a seed saver in Kingston, Ontario, Canada can expect to be doing in their seed garden. They therefore occur throughout the growing season, and we recommend you view them in that order at the appropriate time of year, but you can review them anytime online. This is Robert Moak on the left, my predecessor, and two of the Sisters of Providence of St. Vincent de Paul in the photo. These are not gardening workshops. Gardening is involved, of course, but there are many great gardening resources out there, so we will leave you to find them while we focus on seed saving. I myself was a professional gardener for many years before I thought to save seeds of my own, but now I find it a very enriching, meaningful activity, and I hope to facilitate that same reverence in you. Plant varieties that for thousands of years have been cultivated by humans are living beings in direct, reciprocal relationships with humans. providing us with nourishment and beauty while we provide them with a safe nursery for their seeds and a healthy growing situation for them as plants. This comes to the heart of the kindness of the mystery of creation. To paraphrase Father Thomas Berry, the universe is a communion of subjects, not a collection of objects. I wish you awe and wonder on this journey to saving your own seeds. So this will be part 3 of our seasonal series, which we have named Flowers and Pollination, Weeds and Well-Being, since at this time of year it's all about observing and interacting with all 4, including our own well-being as gardeners and farmers after the exhaustion of spring planting is over. This webinar is divided into 2 parts, the first of which is on flowers and pollinators. So this first part is further divided into topics as follows: how flowers make seeds, what is pollination, how pollinators help flowers make seeds, Pollinator Pics, and then after pollination. We may think that flowers are the beautiful parts of a plant that are there for us to enjoy, bringing lovely color and often scent to our ornamental gardens. But for the plants themselves, the flowers are for reproductive purposes only. Their job is to make offspring, i.e. seeds. Flowers make seeds in much the same way we make human babies. There are male and female parts which must combine in some way in order for an ovule to be fertilized by sperm. This is how flowers make seeds generally. However, they have been on this planet for much longer than we have, so unlike us, plants have developed multiple ways of achieving this goal. To quote John Navazio again, this time from his chapter on reproductive biology of crop plants, learning the basic morphology and mechanics of a plant's reproductive system is very important in understanding how to maximize the yield and quality of the seed you produce. The inherent biological processes of the flower and its sexual parts are often the first place a seed grower looks to when a particular seed crop is not performing adequately. That is, when the quality and quantity of seed are below expectations. Seed growers who view learning the ins and outs of reproductive biology as mysterious or too complicated are selling themselves short. The biology behind these processes is elegant, yet very utilitarian to the job at hand, and is easily learned by anyone interested in the wonders of nature and in understanding how a seed is formed." End quote. Perfect flowers, as they are called, have both male and female parts within the same flower. So they produce both male and female gametes, ovules, and sperm. Some flowers are either male or female, not both, and they are called imperfect flowers. Other flowers are perfect in that they have both male and female parts, but the pollen that is produced by the male parts cannot fertilize the ovules of that same flower. It must be transported to another flower that is not closely genetically related, or inbreeding depression will occur. As we discussed in an earlier webinar, the self-pollinating plants with which we should start our seed-saving careers have perfect flowers that can use their own pollen to fertilize their own ovules without any danger of inbreeding. Tomatoes are one such plant, and you can see the tomato flower here from the side. Here's a photo and an illustration of a perfect flower for comparison. You can see what appears to be one female part in the center of each flower. This is called the pistil and is composed of a stigma, a style, and an ovary at the base. The ovary contains ovules, each of which, if fertilized, can form a seed. Pollen grains must get to the top of the pistil, to what is called the stigma, in order to fertilize the ovule. Around the pistil are stamens, 6 in this photo, which look like they are covered in yellow dust. The stamens are composed of an anther and a filament, and it is the anthers that form and release the pollen, which contains the sperm cells. The yellow dust is the grains of pollen that must make it to the stigma. Here we have the same diagram, but with our tomato flower, which has been dissected to show its male and female parts. To the right of the whole tomato flower is the pistil removed so that we can see it. Normally, in most tomato flowers, that pistil is tucked inside the anther cone, and we cannot see it. Here, the whole flower in the center just shows the stigma, the tip of the pistil, sticking out at the top. To the left of the whole tomato flower is the male parts, the anthers, which in tomatoes are fused together to form what's called an anther cone. When tomatoes are strongly self-pollinating, the pistil is contained inside the anther cone, and the pollen falls straight down onto the stigma and germinates there without ever being exposed to the outside world. But sometimes older tomato varieties do have the stigma exposed, as in this photo, which means the possibility of cross-pollination is much higher. It can be very useful to examine your tomato flowers to see if the stigma is exposed or not. You can see this with your eye, so that you know if a variety needs more isolation or separation from other tomato types. Pollination is therefore the transfer of pollen from a stamen to a pistil, or more specifically from the part of the stamen called the anther to the part of the pistil called the stigma. Pollination starts the production of seeds. In this beautiful illustration used by the Bauta Family Initiative for Canadian Seed Security, we see the pollen being formed in and then released from the anthers, the pollen grains magnified, and then the bees inside the flower physically moving those pollen grains from the anthers to the stigma, before flying away with more pollen to move to the next flower stigma. This is how bees and other creatures pollinate, thereby helping flowers to make seeds. We have seen this slide before in previous webinars, so this is just to remind us that the mating systems portrayed here are all about flowers. The structure of the flower is what determines where on this spectrum our plants belong. So the mating systems on the spectrum. The peas, beans, lettuce, and tomato flowers are strongly self-pollinating, and pea flowers may not even open until after the pollination has occurred. So notice that tomatoes are a little bit further along the spectrum than peas, and that's because of that, the possibility of the stigma protruding. So for our self-pollinating or inbreeding plants, the lettuce, peas, beans, and tomatoes, pollinators may not be quite so helpful, but in some cases they are still needed. So pollinators primarily help tomato flowers merely by shaking or agitating them. Pollen inside the flower, the anther cone, will be shaken off the anthers and onto the stigma, all inside the cone, causing self-pollination. However, as we noted, some older varieties of tomato will make pollen available and will cross that way. And this is why tomatoes are a bit further along that spectrum. Because if a bee were able to access some pollen from another tomato variety, it could easily drop some of that pollen on the stigma of this tomato flower, seen sticking out of the anther cone. Bumblebees will hang upside down on tomato flowers in order to shake some pollen out. And this is, as we mentioned, primarily a concern with the very old heirlooms that are almost wild, closer to wild. So that puts tomatoes further along the mating spectrum. Here are some educational model flowers we have made. On the left, a perfect flower with both male, yellow, and female, which are green, parts. On the right, we have imperfect flowers, one male flower and one female flower. In both cases, quote-unquote bees, or children and sometimes adults, shake pollen, which is represented by potato starch, from the male parts and transfer it to the female parts. So they get the experience of being a bee. So pollinators are helpful. For most of our food crops, bees and other pollinators are actually essential, not just for seed set, but even for fruit set. In other words, without pollinators, we wouldn't have food, let alone seed for next year's food. Look closely and you will see, going clockwise, a black wasp on the milkweed flower in the top left, a lovely orange moth, a delicate whitish-green butterfly blending in with a leaf, and our bumblebee friend again. And of course, other pollinators include humans, wind, water, and more. After pollination, the pollen must actually germinate on the stigma and grow a pollen tube, which is what actually fertilizes the ovule to form a seed. The pollen tube carries the sperm down to the ovule. The more viable seeds you get, the more pollen tubes had to successfully deliver sperm cells to individual ovules. Part 2 of this presentation is called Weeds and Well-Being. The reason for the well-being focus is not only that many weeds are edible and full of health benefits, but also that we mustn't get wrapped up in the unhealthy mindset of feeling pressure to remove every single tiny weed from our gardens. Here are our topics for this section. What is a weed? General thoughts on weeds, and what do weeds have to do with seed saving? The Oxford Dictionary says a weed is a wild plant growing where it is not wanted and in competition with cultivated plants. I say a weed is a non-crop plant. I say this because it may be beneficial, harmful, or neutral. Status may change at different points of the life cycle and different growing sites. Beneficial weeds may include, but are not limited to, lamb's quarters, purslane, mallow, pigweed, dandelion, and pictured here, stinging nettle. Harmful weeds may include, but are not limited to, grass of almost any kind, bindweed, Canada thistle, chemically dangerous weeds such as giant hogweed, parsnip, and poison ivy. We must be genuinely mindful in the process of weeding whenever we are able. In the past, weeds were pulled, turned under, sprayed with chemicals, and otherwise battled with no questions asked. We humans waged war against this enemy without giving it much thought. I believe we are now called to question this attitude, to acknowledge that nature has her own wisdom, and therefore if she has grown a plant there, there must be a reason. This beautiful bull thistle provides safe shelter, food, and other needs for many living beings, such as pollinators and birds, beings we need in our gardens and farms. Remember, many of the plants we call weeds were brought to this country by immigrants as cultivated plants, useful as foods and medicines back home. Before pulling out or destroying your weeds, take some time to look them up in case they have some interesting benefits. So on the one hand, you can see that you'll have to look closely at this photo to see them, but this sow thistle is unhealthy. It's covered in aphids, while its crop variety neighbors remain aphid-free. So perhaps some sow thistle is a good thing, as long as its seed won't get mixed in with your lettuce seeds. Of course, we should not allow weed plants to crowd out our seed crops. This could result in inferior quality seed. However, allowing our hardiest crops some competition may show us some desirable characteristics as well. On the other hand, the seeds of these two plants are very small and look very similar, and we do not want them to get mixed in together at harvest. This is a particular problem in this area. There may be other plants in your garden whose seeds resemble and mature at the same time as your crop seeds. So the photo on the left is of a lettuce plant going to seed, and the photo on the right is our sow thistle, again, going to seed at about the same time. Now we want to save the seeds of the lettuce so we can plant them in future years and eat lettuce. We don't want to save sow thistle seeds necessarily. They are perfectly capable of saving themselves. Mixing of seeds is not a good idea in general, because you may wish to share your seeds with other gardeners at some point, and they won't want your seeds if they have some weed seeds or other seeds mixed in. When you buy a lettuce or salad mix, the seeds are usually grown and cleaned separately, and then clean, good quality seeds are mixed together in certain proportions as the very last step before packaging. The grower still doesn't want weed seeds mixed in. In the case of the cross-pollinating crops or outbreeding crops, there's another good reason to weed. The photo on the left is a very common weed in our area called Queen Anne's lace. The photo on the right is a variety of domestic carrot called oxheart. These two plants look the same because they are. They are both botanically called Daucus carota, and because they want to cross-pollinate, they will happily cross with each other. Rest assured that Queen Anne's lace genes will mostly win, and you will find when you grow out that seed that you have lost your fat, juicy, colorful carrot roots. If at some point you would like to try growing carrot seed, which I would encourage you to do, You will have to take measures to ensure that no Queen Anne's lace is blooming at the same time and in the same vicinity as your carrot crop. And weeding is one way to do this. This is wild parsnip, which is another concern in our area because it will cross with parsnip. And in other geographical regions, there are other weeds that are closely related to our crops that may cross-pollinate. Some of us begin our seed-saving careers by saving weed seeds without thinking much about it. But if you enjoy eating a certain type of weed and you deliberately let a few plants go to seed so that more comes up next year, then in a way you have saved that seed for your own future use. Purslane on the left is a very yummy salad green, and dandelions on the right have many benefits, and the seeds can even be saved for use as sprouting seeds in winter salads. Dandelion flowers are also one of the first nectar sources for our pollinator friends in the spring. And this is a photo of my favorite weed, Chenopodium album. I always let some lamb's quarters go to seed so that I will be sure to have some next year. I tend to weed, i.e. harvest, this plant by cutting the whole plants down early in the morning and stuffing them into bags so that I can eat them for dinner that night. And remember, pollinators love weeds. These are some photos by Sister Lucy Bethel, who has gotten some lovely photos of insects interacting with various weeds and flowers. So thank you for joining me for this third webinar of our series. Here is our resource list as usual. Give you a moment to copy those down. And I hope you can join me for the next one, which will be on harvesting our seed crops after the flowers have done their job. Sorry, there's the resource list I recommend in hopes that you wish to delve deeper into seed-saving knowledge. And thank you to the Sisters of Providence of St. Vincent de Paul for their ministry of the Heirloom Seed Sanctuary and for these webinars, and to the Bauta Family Initiative for Canadian Seed Security, also for their support of these webinars. Have a great day.